Hi, today we're going to be talking about adding and subtracting fractions. And my name is Lauren, and my group members are Monica, Naomi, Al, and Wendy. So our Common Core state standard for this is understanding addition and subtraction of fractions as joining and separating parts referring to the same whole. On day one, we're going to be addressing adding fractions, and Naomi and Wendy are going to go into more depth on that. Day two, we're going to be talking about subtracting fractions, and Al and Monica will be going over that one.
So as my group member Lauren mentioned, on day one, we're going to be adding fractions. Specifically, we're going to be learning how to add fractions with like denominators. So for our objective for the day, students will be able to recognize parts and wholes both visually and numerically and add fractions with like denominators. So the first thing that they're going to do is a warm-up. This is going to be from 11 a.m. to 11:10 a.m. And we're going to go over vocab terms like fraction, numerator, and denominator. These are all terms that they should know prior. So these are all terms that they had learned in at least third grade. But we're deciding to review them over again just so they can see how all those parts of a fraction relate to adding fractions. So a fraction is a number that represents part of a whole. A numerator is above the line of a fraction and tells us how many parts we have. And a denominator is below the line of a fraction and tells us how many parts are in a whole. So we're going to do this too by showing them a visual representation of what that looks like. So their first example that they're going to receive is the pizza example. So we're going to explain to the class that one whole pizza has 8 slices. So one slice can be represented by 1/8 as seen in the image below. And this is because, as we had mentioned earlier, the denominator represents how many parts of a whole we have in total. So then we're going to ask the class to identify the fraction of pizza slices out of a whole for the left side of the image. So in this case, they would have 5/8 slices of pizza. Then we would ask the class to identify the fraction of pizza slices out of a whole for the right side of the image. And then that would be 3/8 slices of pizza. Lastly, we would ask the class what fraction of pizza slices they would have together if we combine all the slices. So in other words, we would ask them what their answer would be if we added 5/8 plus 3/8. And in this case, we can see it on the visual to the right, that 5/8 plus 3/8 would give us 8/8. And this would be their introduction to adding fractions.
So on the same day, students will get a second example of adding fractions by using a number line. For the problem, we'll be using 3/5 plus 1/5, and that will be on the number line. So when creating our number line, students will look at the denominator because that's going to be the number that represents the number of equal parts in the whole. In this case, there's 5, so the student will start at 3/5 and add 1, since the numerator of the other fraction is 1. And based on the numerator, that's the number of jumps they're gonna get, and when they jump, they will land on their answer, which is 4/5 in this example. And then that's gonna be 2 examples that we show, and we want to make it known to the students that the denominator stays the same because the parts of the whole don't change. The only numbers changing will be the numerators because those are the numbers that we're adding. However, in the next slide, we will have whiteboard time, and each student will take out their whiteboards. We will give 5 examples, and in each of these, students will have to use a number line or draw a picture to determine their answers. And after each problem, the teacher will give them feedback based on that. And then for the last 15 minutes of math time, the students will work on a worksheet that the teacher will be handing out, and it's this one right here. And that's going to be it for adding fractions.
So for day 2, we're going to talk about subtracting fractions. So the objective will be, the students will be able to subtract fractions with like denominators. And the first thing will be a review for about 5 minutes. So like Naomi said, to go over the vocabulary terms. So the numerator, the denominator, and whole, and subtract what they mean, so they're able to understand how to solve the fractions.
Sorry. The day 2 warm-up is to remind students that the same principles they learned for addition apply to subtraction. But instead of adding the numerators, we subtract the numerators, keep the denominator, and in this visual, they can see how when we take 1/2 from the whole of the cake, we still have half of the cake remaining. In this way, we are modeling with mathematics, reasoning abstractly and quantitatively, and making sense of the problem. Again, we subtract the numerators and keep the same denominator. In this slide, we move on to a more complex problem modeled with a larger cake cut into 10 equal pieces. We have a whole cake cut into 10 equal pieces for a party. Each piece is 1/10 of a piece of cake. Because the numerator represents the individual pieces and the denominator represents how many make up the whole of the cake. Once you start serving the cake, you take away or subtract 1/10 at a time, as represented in the picture, which has had 2 pieces taken away. The picture also shows how we would write this problem as an expression. So we had 10 pieces of cake, which is represented by 10/10, and we took 2 pieces away, which is represented by the 2/10. This picture shows what the subtraction problem will look like as a concrete example. With the cake as an abstract example, with the equation, reminder that like in addition, the denominator stays the same. The only numbers that will change are the numerators, and those are subtracted just like a regular subtraction problem. Again, by using the cake model, we are modeling with mathematics, reasoning abstractly and quantitatively, and making sense of the problem and persevering in solving them. Make sure everyone understands this cake visual before moving on with some example problems, and ask the kids to hold up their fingers on a scale of 1 to 10, 10 being the highest, understanding completely.
As we go on during the day, explaining subtracting fractions, when solving subtraction fraction, use visuals to help students understand. So one visual can be area model. So for this area model, we have 6/8 minus 2/8 equals 4/8. So on the area model, we have the 8 squares. So and then 6 would be shaded in and 2 would be X'd out because we're taking away. So then we have left the four that are just blue. And then another way to solve will be using the number line. So in the number line, we would write the numbers by always starting with 0, and then we'll write as in 1/8, 2/8, 3/8, 4/8, 5/8, 6/8, 7/8, and 8/8. So when we do the jumping, the numbers would be all there that need to be jumped. So and then we would start with 6/8, and then we would go back 2 because we're taking away 2. So and then when you go back 2, it will land on 4/8. So when solving the subtracting fractions, it's good for the students to have like different options other than just doing it in pencil. So if they want to see visually, they can do the area or the number line. After that, we would do just a small, the teacher would do just a few problems just to review and go over, just to make sure they have an understanding for about 10 minutes, and just to make sure that they can use the area model or the number line to solve the examples. So it'll be just a few 5 to 6 problems, just to make sure they have an understanding of what they're going to do for their independent worksheet. And after reviewing subtracting fractions, the last thing the students need to do at the end of math will be the activity independent work, which will just be a small worksheet with some problems, which it should be take about 20 to 25 minutes or so. And as the teacher walks around, make sure that the teacher supports if the child needs extra understanding if they're having a hard time at the end of math.
Finally, addressing some misconceptions. One of the biggest misconceptions that a lot of students face when adding and subtracting fractions is adding and subtracting straight across. So for example, as you guys can see in the kind of greenish blue misconception visual representation, a problem like 2/4 plus 2/4 plus 2/4, a student might take that and find the answer 4/8 by adding 2 and 2 and 4 and 4. But it's really important to show them the visuals and express the vocabulary. So like all of my group members have mentioned, in their lesson plans, there's going to be a pretty heavy review of vocabulary, because understanding the vocabulary, what a numerator represents and what a denominator represents, is really going to help those students to not make that mistake. So the numerator being the number of parts out of the whole. So if there's 4 pieces, that's going to be the denominator. And if it's 2 out of the 4 pieces, the fraction is going to be 2/4. And that denominator, once again, is the total number of parts. So on the green/bluish color, that is the misconception visual representation. And from there, you can see what 2/4 looks like, what another 2/4 looks like, and how when you add that together and end up with the answer 4/8, that the answer ends up being about the same size, actually the exact same size as one of the pieces in the addition equation. So when you're adding 2 pieces together, that answer should be bigger than each of those individual pieces. So it shouldn't come out with the same answer. Whereas in the actual visual representation in orange, students are able to see what 2/4 looks like, what 2/4 looks like. And when you put those together, when you're mixing them together, you get 4/4, which is also going to be helpful to show them the visual of what one whole looks like, and how each part of the fraction, each 1/4, is a piece of the one whole. So showing them visuals and also making sure that they're really clear on their vocabulary is going to be a huge piece in making sure that students are not adding and subtracting straight across. Finally, implementing a growth mindset is something that's really important with students, because fractions can be something that can be difficult for students. It violates a lot of their base 10 math learning that they have throughout their education. So it can be really confusing for them to try and add little pieces of something and understand that a fraction is smaller than one whole. So as students are making mistakes, it's really important to provide positive affirmation. And not providing positive affirmation only when they're right, but providing them positive affirmation whenever they're making effort. And you should be acknowledging their thinking. So like a student who would be making a mistake like this, acknowledging that you appreciate their effort, that they made great effort. You can see how they could have come up with that answer, but that they need to keep trying, and that you know that they'll get it, and that you know that they can do it. And as they learn, this pathway will form in their brain. Something that's really important for students is explaining to them the importance of making mistakes, how making mistakes is important for connecting neural pathways in the brain, and how the more mistakes they make, the faster they're failing, the faster they're learning. So giving them praise not only when they're making, when they're doing something correct, but giving them praise when they're giving their best effort. So when you're doing that, students may start by not saying that they're not math people or they're not good at math, but the more positive affirmation that you give them, the more confidence they'll build in themselves, and the more they'll believe in themselves to develop a mathematical growth mindset where they know that they're capable of doing the problems and learning the math, even if they struggle with it at first. But that is all of our presentation. Hope you guys enjoyed, and that is how we would do adding and subtracting fractions.